Hi all, I'm Dr. D. Madhavi. Today we are going to discuss a linear data structure called stack. Stack is very similar to your list. It stores homogeneous elements. It is like a container open at one end and it is associated with two operations called push and pop. So any data structure need to deal with data. So how to use it, how to store it, how to process it, how to gain knowledge from it, and how to keep it secret. So now we are going to focus only on storing and process, because a data structure is an efficient way of storing information in an organized way such that you can process the information very quickly and easily. So stack is one of the data structure which we are studying today. So these are the elementary data structures: arrays, lists, stacks, queues, trees, and all. So this is the diagram of an array, a representation of a linked list. This is a stack, this is a tree, and this is a queue. Okay, it is open at both the ends. From one end we perform insertions and from one end we perform deletions. So in some languages, these are basic data types. In others, they need to be implemented. So list is a data type in Java, similarly array. Okay. In C, we have to implement a stack, we have to implement a queue, and we have to implement a trees. Okay, so it depends on the type of the programming language you adopt. Okay, data type is with few operations, whereas data structures, they have additional operations like searching, sorting, and all. So stack is a last in first out data structure. So it maintains a list for which insert and delete are allowed only at one end of the list, and always it is pointed to by a pointer called top. Top always points to the top of the stack. So here I am inserting different colors here. So now if I want to insert the color blue, so it will be inserted only at the top of the stack, and top will be again pointing to this. So this is the insertion operation called push. We always use push for insertion in a stack. Similarly, pop is used for deletion. So if you pop, the lastly inserted element will be deleted first, and top will be decremented by 1. If you repeat the same operation once again the slot pointed by the top will be removed, that is yellow will be removed first and then top will be decremented. So now top will be pointing to the red color. So in this way, insertion and deletion operations are carried out in stack. What is this good for? The applications of stack: page visited history in a web browser. So if you observe web browser, you can see the left arrow and right arrow. You can see the left arrow like this. Left arrow always indicates the previous page that you have recently visited, latestly visited, and right arrow indicates that you visited whatever page you visited after the current page, that will be appeared. Similarly, undo sequence in a text editor. So when I type some text here, okay, when I modify this text to say some parrot, okay, and still I want to sits. I want to modify still. Now I'm pressing undo operation. So when I press undo operation, the recently typed word is deleted first. And once again, if I press undo operation, so the second one is there. So the last in first out nature is also observed in this undo sequence in a text editor. So saving local variables when one function calls another, that is in nested function calls, okay, stack is also used. You can write code in Python, code in C, code in Java, and we are doing the same thing, that is implementing a stack, whatever may be the programming language. So an abstract data type defines the property or behavior of the stack by specifying the data that is required to operate that particular data structure and the methods that are associated with the data structure. So these are the very basic types of data types, that is integer, real, float, boolean, etc. character, and then arrays also, an array of images. And then you can have operations associated with it. An ADT specifies the data that is stored, operations on the data, and any error conditions associated with. I'm going to demonstrate the stack operation using this animated video. So now I'm going to insert something. So initially stack is empty. So I want to insert 11 and I'm pressing this push. So the top is pointing to this 11. Once again I want to insert 22 and pushing 22. So top is incremented and 22 stored here. So top always points to the top of this stack. Once again I want to insert some other element 33 and I am pressing push. So when I push, so top is incremented and in that free slot 33 is placed. Now top is pointing to the lastly inserted item, that is 33. So once again if I want to insert 44, I'll push. So top is incremented to a free location and in that 44 is placed. So top is pointing to the recently entered item, that is 44, the top of this stack. Okay, if I want to insert 55 now, so 55 is inserted to the top of the stack and top is incremented. Now if you press peak always returns the element at the top of the stack. So the top element is 55. Okay. Then again, once again, I want to push some 66. So top is again incremented and in that free slot 66 is placed. Now top is pointing to the top of the stack element. Similarly, if you press pop, then top is decremented and the top element is removed. So once again if you press pop, 55 will be removed and then top is decremented. Similarly once again if you pop, 44 is removed and top is pointing to 33. So once again you pop, so 33 is removed, which is on the top of the stack, and top is decremented. So when you delete or pressing this pop, then top is decrementing by 1. If you want to insert again another number, 111 this time, okay, so top is incremented. Once again if you want to push another element, top is incremented. Once again if you want to push another element, top is incremented. So when you are pushing, that is inserting an element, top is incrementing and it is showing. Now if you press peak, so the top element is 333. Okay. Now if you pop, the top element 333 is removed and top is decremented. So whenever you push, top is incrementing, and whenever you pop, top is decrementing. So like that, if you continuously pop, okay, all the elements will be removed and stack is empty. So this is how we can operate stack. So this is the stack ADT. So piling up of books and a single ended container. You are putting all the plates one by one, that is pushing plates one by one, and when you remove the last plate that is pushed will be popped. So these are the various operations associated with push. Insert element at top, and top or peak will return top element, and pop is used to remove and return top element, and is empty is a test for emptiness. So suppose it should not allow you to delete when there are no elements in the stack. So is empty will return a boolean value that is true if the stack is empty, else it will return a 0. So first you check the emptiness and then proceed for the deletion operation, that is pop. Similarly for pushing also we have to see whether there is space in the stack or not. So for that, is full is another method to check whether the stack is full or not. So stack is full means you cannot further push another element. So these are the various methods or operations associated with stack. Okay, whenever you try to push an element into a full stack, it should generate an error message saying that the stack is full and the push operation is not possible. Similarly, whenever you want to delete, pop an element, first you have to check whether it is empty or not. If it is empty, it has to display an error message that so stack is empty and deletion pop is not possible. So that is how you operate stack. Any questions? Thank you.